Awesome. Thank you so much, Chris. I'm so excited to be here talking about probably my favorite topic. So I joke that by day I am a STSM architect engineer, and by night I'm a professor. You know, some of what I'm going to talk about is research based, and some of it is very practical, technical based in what I see and what I do on the day to day. All right. So what I wanted to start with, vulnerability chaining has been around for a long time in the context of vulnerability management. So we have CVSS, the Common Vulnerability Scoring System. And when it comes to CVSS, there's a user guide that walks you through all of the different metrics, how they actually determine a score or a calculation for a vulnerability. What's interesting about that is that vulnerabilities scored low, medium, high to critical is sort of our baseline for what we have for vulnerability management. And then we add context on top, system, maybe our high valued assets or data that's really important to us, or external facing assets that we might be most interested in protecting. But when it comes to vulnerability chaining, the CVSS user guide discusses that very specifically as low and medium vulnerabilities that are combined together to create very serious critical attacks. So in the last, I would say maybe 4 to 5 years, that discussion, but prior to 4 or 5 years ago, that discussion was very, I would say, loosey-goosey is my research term that I like to use for that, in that we were talking about it in a very abstract way. We were talking about how vulnerabilities could be chained together or how they might be chained together. And on the red teamer side or on the pen test side, that was a very familiar concept. On the blue teamer side, it wasn't something we were necessarily, investigating or looking at very heavily at that time, back in 2017 when I started the research. But vulnerability chaining has evolved and changed over time, just like technology does. So originally, when we were talking about low and medium vulnerabilities, that was anything that had a CVE ID. But now we're talking about vulnerabilities that exist across environments. Our technical ecosystems are so complex now. We don't just have necessarily a data center anymore. We have a cloud account or multiple cloud accounts. We might have containers or infrastructure as code. Our environments are changing so much, and there will still be our fair share of CVEs that we deal with in an environment. But a lot of vulnerabilities don't necessarily have a CVE ID. And so when we're talking about vulnerability chaining, it's anything in the environment that could be vulnerable. Identity and access management is a big one. The end goal of vulnerability chaining, and I'll give an example in just a second, but the end goal of chaining vulnerabilities together is either full system compromise or to gain access to credentials or privilege escalation that someone may not be able to get just by exploiting one vulnerability on its own. What's kind of interesting about that as well is that vendors in the last few years, 3-4 years, have started to publish when there are vulnerability chains in their own, environments or their own products or applications, tool sets. So you could see how vulnerabilities could be chained within a product or maybe within an environment. But now we're also seeing, you can see how vulnerability chaining how vulnerabilities interact to create vulnerability chains that can cause some serious damage. One of the other interesting things about vulnerability chaining is that we're also talking about network security and network engineering, especially when it comes to cloud accounts and managing cloud accounts. We see a lot of the statistics change year to year, but we continue to see that misconfiguration in cloud accounts, misconfiguration for external facing assets that are meant to be internal facing, those types of things we continue to see as, potential entry points for somebody to get into those systems. But just because they gain access may not mean that they get access to what they want. So they might gain access to an account, but maybe they don't have the proper privileges or administrative access that they're looking for. So they may hop around system to system or hop account to account until they get to the right account that they're looking for. So that was vulnerability chaining, kind of the history, the very quick history of vulnerability chaining. The challenge around that is identification. How do we identify vulnerability chains in our environment. There are some really good tools out there that you can use that can help. Looking at your network environment, getting an idea of what systems are connected, what vulnerabilities exist, what vulnerability chains might exist in your products. Those are all good places to start. But what's been interesting is that we have, in the last few years, this very big boom in AI, both from a user or developer perspective. So me as a developer, I want to use AI to help make my life easier, but also from a user and system context where people may be developing, using and leveraging AI or consuming AI products that may be from a third party. Maybe they're doing integrations with a third party, or they're consuming data and building their own. Maybe they're leveraging a model to help build their application. So there's a lot of different uses that we're seeing with AI across every different environment. What I find so fascinating about that related to vulnerability chaining is it does make the vulnerability chaining experience both more complex and more simple at the same time, which is always interesting. So in the last couple of years, the way that AI has shaped development, we're using a lot more tools to help us either code or develop applications. And it can be difficult to create really complex development environments that are secure from the ground up, just in general. But when we're leveraging different types of tools or different types of mechanisms and methods to build our environments, we may be introducing vulnerabilities without, even knowing that they're being introduced. So I wanted to cover a couple of the different areas where I think vulnerability chaining is most interesting to look at, especially with the advent of AI and the way that we're using both LLMs and SLMs, how we're consuming data, and also using that data in our systems. And the first one is infrastructure. Whether you're leveraging AI to build a product or you're building your own product using AI, there's still that classic infrastructure component in some capacity. Maybe it's a development environment, maybe it's a cloud account that you've got multiple systems running, maybe it's multiple cloud accounts. The connectivity between systems remains the same. The interesting thing is we have a new attack vector. So for example, if you are using or leveraging or building your own model that might be susceptible to injection attacks or maybe injection attacks or model poisoning. There's a couple of different ways that attackers are starting to leverage different mechanisms to get access to those systems, and they might be interested in the model, but they might also be interested in something else. That model could potentially lead them to the infrastructure if they were looking for a different data set or looking for a different account to gain access to something else. So it's another entry point we have to think about, especially as you're consuming and using these models. It's just like doing a third-party risk assessment, understanding, kind of where does my risk exist, both internally and externally, from the services I'm consuming. Identity and access management, another one of my favorite topics around vulnerability chaining, particularly because overly permissioned accounts, we continue to see that in cloud environments, but also when it comes to leveraging and using APIs, which is very important when you're doing any type of work with AI or models, or building your infrastructure to manage and develop that. SSO, single sign-on, passkeys, password management, all of those things are still very much in the picture and can contribute to and or inhibit vulnerability chaining attacks from occurring, which when we're talking about very complex systems, if you're building a massive infrastructure and leveraging an AI model for some use case, what can happen is you have to give access and give access to either the model or to people to have access to the model. It can start to be this very complex IAM picture, which can be difficult to track unless you have some type of tooling or dynamic access model where you can automatically remove permissions or reduce permissions depending on, kind of what's going on in the environment. The other aspect of this, so vulnerability chaining in a classical sense, was talked a lot more about technical components, the actual vulnerability or vulnerable component in a system. with the advent of multiple different uses of AI, including deep fakes, and vishing. Vishing is even getting more sophisticated with the way that people can leverage someone's voice to make it sound like it's somebody else. So you can make it sound like somebody you know or somebody you're expecting to call you, even if it's from a different number. And of course, social engineering. There's been a number of different types of attacks that have kind of sprung up around this. Sure, in the news, there's been a lot of people using deep fakes or imaging to make them look like a different person, either to try to get a job or to leverage it for some other reason, some other social engineering reason. So there is this human factor element that I think we have to bring into the vulnerability chaining picture, especially with the advent and really the transformation of AI in our technical space. So what can you do about it? What should you be looking for? What should you be thinking about? So I mentioned a few different things that I think can be helpful, especially if you are not as familiar with the vulnerability chaining topic itself. There's a lot of great resources available on vulnerability chaining, different types of examples and attacks. But identification, just like if you were doing a typical vulnerability management exercise, you want to know where your systems are. Where do they touch AI, and what does that mean? Does that mean they're using a third-party model? Does that mean you're consuming it internally? Are you building products with AI in them? Are you consuming products that have AI in them that are automatically turned on or you can turn on? Understanding where all of those pieces are can be really helpful to kind of put together that map to see where exposure might exist. Access management, of course. So where do accounts have access, and not just in a kind of a traditional sense, but where does the same account have access to multiple systems? Essentially, if a particular account were compromised, what would it have access to? And that may include, your LLM or your actual whatever model it might be that you're using or consuming. So to see who has access to it and what amount of access do they have to that system. Connectivity of systems, I think this is going to continue to be a really important component of vulnerability chaining, in that network engineering and understanding how systems are connected and where our data is flowing is going to be super critical to making sure that we're closing the door in the right places and opening the door in the right places. That's really going to come down to network engineering and segmentation. Human factors. How do we use our AI tooling? Where are we consuming it? How do people use it? Is it expected? Is it unexpected? How are people actually leveraging this in our environment? And maybe how are people interacting with our systems? How can we kind of be aware of that in our environment to make sure that we understand how people could use it in the right way and maybe in the wrong way as well? And then technical debt. Where have I implemented AI or some type of AI system that might have access to legacy vulnerabilities or legacy equipment, end of life and support software? Where does that connect? Because if there is sort of a window is opened into a legacy environment, or there's some connectivity there, it could be opening up for potential exposure and risk in that environment. So I highly recommend, just like a typical vulnerability management practice, but knowing where your very important digital assets are, so you can make sure that they're protected from any legacy or vulnerability data that you don't want it to have access to. And then I put my LinkedIn there, and then I'll be around to answer questions too. I think with a minute to spare, Chris.